Hello guys. So today I thought to teach you the motion in two dimension. So far we actually discuss motions completely vertically or in a horizontal direction, but this time our motion is in 2D. Okay, so this is an example projectile motion. So this motion is completely under gravity, and also first of all, I'm sorry because I don't have any proper way to record this tutorial. I am in my lab, so I hope this would be okay. So the problem is like this: show that the trajectory of a projectile is parabola. So this is our first proof. Okay, we are going to prove this. The trajectory of a projectile is a parabola. So the first of all, we take here two assumptions. The first assumption is the acceleration due to gravity is constant, meaning g is constant. So this is a reasonable assumption because we say, for example, the range of this projectile is very small compared with the radius of the earth. So this assumption is a reasonable assumption. And the second assumption is the air resistance is negligible. So we assume there is no air resistance, so that this motion, by assuming that, we are going to check what is the trajectory of this projectile. Okay, so this is our vertical axis, y-axis, and here is our the horizontal axis. So actually we throw an object with an angle theta I, right, with a velocity vi. So this is the initial speed of the projectile. So if you throw this object, so we all know the object will follow a path like this, okay, something like this. So we have to show this path, this trajectory is actually a parabola. So how we are going to show this? So that is our task today. So it's not really complicated. So the first what I'm going to do is I'll take this angle is theta I. So if I throw a ball with a velocity vi, I can divide this velocity into two components. One is in the horizontal, other one is in the vertical direction. Okay, so the horizontal component is, I will call vxi, okay, in the x direction vxi, and in the vertical direction we have vyi. So it's not really complicated if you know bit of about vectors. You see, for example, if you have a vector, okay, in, let's say this is our x-axis and y-axis, and if you have a vector A, and if I say this angle is theta, we can actually divide this vector into two perpendicular components. Okay, one is if you divide along this theta direction. So this is our theta. If you divide, so this is my vector. So if I divide this vector along this theta direction, we call A cos theta. So this is my A cos theta, and this vector we call vector A sin theta. So this is the idea. So I'm using here the same. Okay, so this is my vector. If I divide along this direction, I will get vi cos theta, and this side I will get vi sin theta. Okay, so we found the initial vxi, the vxi and vyi. Okay, so now I am going to use s equal to ut plus half gt squared. So this is, we already studied this. So if you apply this equation horizontally, we know the gravity, there is no gravity in the horizontal direction, so I can say g is actually 0 in the horizontal direction. And I am okay, so let's say I'll take an arbitrary location. Okay, so you throw the ball here, so the ball reaches the point somewhere here. Okay, so I will say this coordinate is my xm. Okay, this coordinate is xm, and here it's my ym. Okay, and let's assume time taken, okay, to reach the ball from here to somewhere here is t. Okay, time taken is t. So I'm using now xm to reach this point in the horizontal direction. This is my xm, is equal to the horizontal velocity is vi cos theta I, here we said that, into t, because we said in the horizontal direction no acceleration. Okay, so this part become, actually this will be 0. And remember, in the projectile motion, the horizontal component doesn't change at all. Okay, this vi doesn't change at all because there is no acceleration to change this speed. Okay, the velocity, you see, even here we'll be having vi cos theta I, and here also. Okay, it doesn't change at all in the horizontal direction, only in the vertical direction it will change. Sorry. So what is our ym? Ym is, if I use the same equation, now the initial speed is actually vi sin theta. Okay, so this is sin theta I. Okay, I'm sorry, this is sin theta I. So vi sin theta I, because we said this is actually theta I. I put I stand for, I mean, you see, you can change the angle. Okay, this index actually indicate you can change the angle. The angle is actually is a variable quantity. So vi sin theta I into time t minus y, this is actually minus sign. Remember, now I'm using the same equation in vertical direction. Okay, I'm using in upward direction, but this gravity is downward, so that's why here I'm having a minus sign. So minus half gt squared. So this is my second equation. So what I'm doing is, now from the first equation I can subject t. So t will be xm divided by vi cos theta I. Now I'll take this from equation 1, I'll find what is my t, and I'm going to substitute in the second equation and substitute into equation 2. So if I substitute in 2, so this is my ym is equal to vi sin theta I. I'm sorry, here I missed theta I. Okay, sin theta I into, for this t I can substitute xm divided by vi cos theta I minus half g. For the t squared, again I can square this factor. Okay, so now you see I can cancel out this vi and vi. Sin theta I by cos theta I can say tan theta I. So ym is equal to tan theta I into this xm minus g is on the top. 2, if you square this one, vi squared cos theta square, into here you have xm squared. Now if you observe this equation, you can see, right? So this is very similar to our the equation of parabola. So this is our y and this is our b x minus this factor is our a, okay, ax squared. So I hope you remember the formula for parabola: y equal to ax squared plus bx plus c. Okay, so from the equation you see, you know if a greater than 0, you will get a parabola like this, something like this, right? But if a less than 0, you will get upside down. Okay, so it would be something like this. So you see, it's because in our problem we are getting a minus sign here, so it is clear. You see our parabola is upside down. Okay, this because this quantity is a negative quantity. So yeah, so that's it. This is the equation of parabola. I hope you got the idea. Thank you for watching.